Okay, so we're gonna continue from there. But ano bang napag-usapan last time? Last time, we were able to talk about uh, the field and order actions, no? Yung field action for R, although dinaanan lang natin ito. And ano ba yun? Order action. As well as we talk about countability of sets, no? Ibig sabihin when we say that a set is countable. Well, anyway, the field actions, actually marami yan, no? It talks about the properties of addition and multiplication in general, no? And the field action actually allowed us to perform arithmetic, no, in R. Pwede ka mag-add, mag-multiply, mag-subtract, etc. No? On the other hand, the order action allowed us to talk about uh, relative sizes of real numbers. Which one is bigger? No, which one is, and the properties of inequalities were also discussed. And then, ang huling-huli yung countability, yung napag-usapan natin na hindi lahat ng infinities ay pare-parehas, no? Some infinities are bigger than others, right? Yung pinakamaliit na uri ng infinity, yun yung countable infinity, no? Yun yung infinity na kasing dami ng set of counting numbers. We found out that a lot of sets is really countable, but you know, there are actually a lot of sets which are not countable as well. Na-prove natin last time that R itself is an uncountable set. Hindi siya countable. So, uncountable siya. So, we're going to continue from here. Sabi ko last time, there are actually three set of axioms that govern R. No? So, we were able to touch the first two axioms. And today, we're gonna talk about the third and the last axiom for R, which is the completeness axiom. But before we can state the completeness axiom, so ganito, no? Yung field axiom will allow us to do arithmetic. Lagay ko dito. Arithmetic. Order axiom allows us to talk about inequalities, no? Inequalities. And the third and final axiom, which is what we call the completeness axiom, ito yung pinaka-importanting axiom sa tatlo in our subject. So wala namang pinaka-importante sa tatlo. Yung tatlong yan importante because they will work hand in hand together. But the third one will actually allow us to do or to talk about limits, which is important in any calculus course, no? Of course. Ano ba yung completeness axiom? But before we can state that, we need to define some terminologies. Okay, so let me share this slide. Okay. Right. So here, we are defining the word, when we are defining when is a set of real numbers bounded. Okay. Ito actually yung ano dyan, yung bida sa definition na to. Okay, so first, let S be a non-empty set of real numbers. So, pwedeng kahit na anong klaseng set of real numbers yan. Okay? We say that S is bounded above. Sometimes narinig ko yung bounded from above. But of course, pwede naman bounded above lang. If you can find a number U, so that the property of this U is that U dominates all of the elements of S. When you say U dominates all of the elements of S, that means to say X is less than or equal to U for all elements X in S. Sa Tagalog, parang lahat ng elements ng S is less than or equal to that particular element U. So you can imagine that if you think of the real numbers as points in the number line, kunwari ito yung number line, a set will be bounded above, kunwari ito yung set S mo. Yan, kunwari ito yung set S mo, yung dilaw. No? You can say that S is bounded above if you can find a U somewhere here. That's how I think about it actually. If for every x in S, kapag kumuha ka ng kahit na sinong x mula kay S, kuwari ito si x, no? Yung x na yan is less than or equal to you for all x in S. So kahit na sino si x si S, sa S, mas maliit or equal siya sa iyo. On the other hand, the set S is bounded below. Ito naman yung kabaligtaran. If a number L can be found that is dominated by every element of X. Ganun siya. Ano sabihin that is dominated by every element of S? It means to say that for all points X in S, X is greater than or equal to L. Or you can also say L is less than or equal to X for all X in S. Naunawaan ba yung dalawang definitions na ito? So far? May tanong kayo before I proceed? Yung dalawang definitions na to, clear? So far? Okay. I will keep on asking you ha, kasi kapag ito yung nagpatong-patong na yung mga definitions, no, sometimes it's getting, tawag nito, nakaka-overwhelm pag marami ng definitions. So I'm going to keep on asking. So please answer in the chat box, okay? Okay, so when do we use the word bounded for the set S? The set S is bounded if it is both bounded above and below. So meaning to say, meron kang bound sa itaas, which meron kang U sa itaas, meron kang L sa ibaba. By the way, hindi ko nasama dito sa definition na ito, but yeah, yung number na U na pinag-uusapan dito, kung ano man yung U na nakita mo, that dominates every element of S is what we call an upper bound for S. On the other hand, if there is a number L that is dominated by every element of S, we call that a lower bound for S. Now, if the set doesn't either, if the set is not bounded, ibig sabihin ng hindi bounded, either it is not bounded above or it is not bounded below, no? Kumbaga, alin man doon sa dalawang hindi mag-hold, halimbawa, wala siyang upper bound o kaya wala siyang lower bound, you say that the set is unbounded. Okay? Halimbawa, you know that the open interval from 0 to 1 is a bounded set. Why is that so? Kasi when you imagine the the open interval from 0 to 1, ganito itsura niya, no? Negative 1, 0, 1, 1. Ang ating representation will be the numbers that are between that are precisely between 0 and 1, not including 0 and 1. So we're not including 0 and 1, and we just talk about those that are in between. Now this set of numbers or this interval actually is bounded above and below. Maraming upper bounds ang pwede nyong ibigay. Can you give me an upper bound? Ay, teka lang, 2 ito. Mali yun. Can you give me an upper bound? Any upper bound? Sige nga, in the chat box, can you type any upper bound for this set? Paano ko nasabing, yeah, 2 is an upper bound. Marami pa. What else? 3 is an upper bound. In fact, any number greater than 2 is an upper bound, no? Etc. Correct. But actually, hindi tayo, ang laro talaga, no, the game for today is not really to get the biggest upper bound because there will never be a biggest upper bound. Ang laro natin for today is kung sino makakapagbigay ng pinakamaliit na upper bound. They get the idea? They get the jive? So for example, 1 is an upper bound. Correct? Tama si Christopher, no? 1 is an upper bound. But can you think of any number less than 1 that is an upper bound? Meron bang number na mas maliit sa 1 that is an upper bound? Wala na. So we think that 1 is the least among the upper bound. mamaya you will find that it will play an important role. Yung pinaka-least na upper bound. Okay. Can you now give me lower bounds for I? Syempre marami, no? 0 is a lower bound. What else? Negative 0.000001 is a lower bound. Yes, 0 is a lower bound. What else? Negative 1, etc. Actually, any number less than 0 is a lower bound. But you see that no number greater than 0 is a lower bound. You know, that's what separates 0 from all the other lower bound, no? Bakit iba yung 0 sa ibang lower bound? Bakit siya natatangi? Kasi meron siyang property na lahat ng nasa kaliwa niya lower bound, pero lahat ng nasa kanan niya hindi na lower bound, no? That's why 0 is a point of interest, just like 1. Si 1 naman lahat ng nasa kanan niya upper bounds for I, pero lahat naman ng nasa kaliwa niya hindi na upper bound. Right? So these two numbers will play an important role later. Yan. On the other hand, the interval j from 0 to infinity is bounded below but not above. You know that very well kasi the interval from 0 to infinity is represented by this. Now, ang 0 to infinity will basically include all numbers greater than or to the right of 0. So you see that in this example, the set the set J is bounded below. In fact, 0 is a lower bound. No, any number less than 0 is a lower bound, but it is not bounded above. Why? It's not bounded above because what? Can't determine number greater than infinity. Yeah, but actually yung infinity na ito is not really a number. It's just a notation. Ang definition ng 0 to infinity talaga na interval, it's just the set of numbers greater than 0. Walang mini-mention na infinity dyan, but yeah, it's basically just a notation. So we don't think about of infinity as an end. Okay? So, why do you think this is not bounded above? Aside from you cannot think of anything greater than infinity. The reason is because kapag kumuha ka ng any element ng j, no? Let's say x is in j, you see that x plus 1 is still an element of j. If x is greater than 0, you know that x plus 1 is still greater than j, and so what? Kasi yung x plus 1 is greater than x. Kumbaga, and for every element x in j, yung x plus 1 is still in j. So, parang basically hindi ka makakahanap ng upper bound. So, basta ma-violate pala yung isa, hindi na siya bounded above, kahit na siya bounded below, unbounded na yun, ha? Kasi to be bounded, dapat both bounded below and bounded above. Okay. So the set of real numbers itself is not bounded below and also not bounded above. You know this very well. Okay? And therefore it is unbounded. How about the set n of counting numbers? What can you say about this set? So for our class, ang set of counting numbers starts at 1. Okay, is this bounded above? Well, obviously it's bounded below. Diba? Okay, how about the boundedness above? Is it bounded above? Ano yung sabihin ng 2? Melvins. Okay. So, ang tanong ko, is it bounded above? So, obviously, you know that this is not bounded above, but why? So, ganito. Pag sinabi niyong no, kasi if you look at the definition, let's work on the scratch paper, okay? So, S is bounded above. Ito yung logic niyan ha. If there exists an upper bound U, no? There exists a U in R such that for all X in S, X is less than or equal to U. Okay? So kapag sinabi mong S is not bounded above, paano mo i-negate yung statement na ito? Kasi ang tinitignan natin dito, paano mo i-justify na hindi bounded above ang isang set? If paano mo i-negate yung ano nito, yung statement na ito sa logic? Paano nag-negate ng ganyan? Paano nag-negate that ng there is or there exists? Ang negation yan ganito, di ba? For all U in R, there exists an X naught in S such that X naught is greater than U. Pag nag-negate kayo, yung there exists nagiging for all, yung for all nagiging there exists, tapos yung statement mo, yung propositional, ang tawag dito, propositional function ninyo ay nag-negate din. So instead of this nagiging greater than. Kung babasahin natin to, tignan nyo. Sabi nito, kahit na anong real number ang i-propose mo, makakahanap ka ng isang element ng set that is greater than U. Kahit na anong U ang i-propose mo na real number, laging may isang element yung set na mas malaki doon. So in other words, if you're going to show that N is not bounded above, pag ang claim no N is not bounded above, what you really mean by saying this is that ang sinasabi mo, every real number is dominated by at least one natural number. Tama ba? Pag sinulat mo in English yung ganitong statement, no, ito yung pagkaka-English niya. Every real number is dominated by at least one natural number. Ang sinasabi mo, pag kumuha ka ng isang real, no, real, may isang natural number na palaging mas malaki sa kanya. Okay? Did you understand? Ang tanong, bakit ito totoo? Bakit totoo na laging may natural number sa kanan ng kahit na sinong real number? What's the truth about this statement? You know, the truth is we think that we understand that. We think that we have a reason for that. But in reality, we didn't have. Paano natin nalaman na may natural number sa kanan ng bawat isang real number? Ang sagot, by experience, no? The way we think about the real number line. But in reality, wala naman sa mga axioms na nagsasabi na ang real number line ay mukhang ganito. Inisip lang natin yan, no? We simply represented it that way. But in reality, wala naman talagang nagsabi sa atin na ganun siya talaga. So we don't really have a special reason to think about R as this, no? Right? Yung pagkaka-arrange yun ng natural numbers na putol-put na gano'n yung order. Yeah, but how sure are you na may mga anbawa? Oo, tama. Ganito yung arrangement ng mga natural numbers because of the order axioms na napag-aralan natin last time, di ba? Ganyan yung order nila, mas maliit ito, mas maliit yan, etc. Pero walang sinabi na may real number sa gitna nito. Inisip lang natin. No? So really, the question is, at this point, we cannot answer this. Wala tayong sagot. But the moment, mamaya makikita niyo, the moment we stated the completeness action, we will eventually justify the answer to this question. Ito yung sinasabi ko sa inyo, no? Most of the questions that will be asked in this subject, actually may mga sagot kayo. And your answer will come from your experience as students of mathematics. No? Lahat naman tayo nagdadaan sa iba't ibang uri ng math, di ba? As students. Pero the truth is, alam ba natin bakit yun yung sagot natin? And in fact, that is the point of this subject. Kaya tayo may magandang subject so we can explain, no? Ibig sabihin, as teachers, napaka-importante na alam natin yung mga rason sa mga tanong na ito. Mamaya kasi, halimbawa, no, maka-encounter kayo ng isang estudyante na itinanong ito. Although, it's not easy to explain it to them, pero at least you can somehow, say that you have an idea why that is true. Okay. Ito na yung sinasabi ni Sir kanina. Kapag may upper bound ka, actually marami ng upper bound. Halimbawa, nakapagbigay ka ng upper bound for a set, let's say U. In fact, lahat ng number sa kanan ng U ay upper bound. That's clear. Na? Mas maliwanag pa yun sa sikat ng araw. Now, what separates, ano ba sa example na to? What separates one from all the other upper bounds of I, no, is the fact that lahat ng nasa kanan ng 1 ay upper bound. That's natural for any kind of upper bound. Pero, ang unique para sa 1 is that lahat ng nasa kaliwa niya, hindi na upper bound. Correct? And that makes 1 a special element for the interval I. In fact, we call I as the least upper bound, or yung mas technical na term, if you want to sound more social, no, you can use the word supremum. But I guess the English one, which is the least upper bound, is tag nito, understandable ng hindi kailangang ipaliwanag. Kasi from the name itself, it's the least among the upper bounds. Okay? Tama ba? Naintindihan ninyo? Now, we use this symbol for that least upper bound. We use sup U, sup S is equal to U, or the supremum of S is U, right? If it has the following property. Number 1, bago ka maging least upper bound or supremum, dapat upper bound ka muna. Pangalawa, why is it the least? Kasi, kapag kumuha ka ng any other upper bound, let's say V, anong relationship ng V na yan sa U? V dominates U. Hindi pa pwede, sabihin, because it's the least among the upper bound, it is dominated by any other upper bound. Did you understand this definition? Why does it match with our intuitive idea of supremum? Naintindihan niyo yung definition na ito? Okay. All right. So thank you for the response. How about the opposite? Kung meron kang least upper bound, wala tayong least lower bound. Kasi you know that if you have a lower bound L, any number less than that is also a lower bound. Na? But kapag lower bound ang pinag-uusapan, ang ating point of interest ay yung pinakamalaking lower bound. Ano yung sabihin ng pinakamalaking lower bound, or the GLB, the greatest lower bound? Siya yung lower bound na lahat ng elements na nasa kanan niya, hindi na lower bound. Okay? Kaya lang we don't want to use that as the definition kasi may word na hindi. Tatandaan nyo, in mathematics, we always state our definition positively, in a positive manner. So you have to rewrite your definitions to make it sound positive. Hindi ka nagde-define ng a number is not rational if, di ba? You don't say that. Kaya ito yung pagkaka-state natin. Ang ginagamit naman yung mas social na pangalan ng greatest lower bound ay infimum. And it's written inf S. Okay, so you will find that this is used if, first of all, dapat W is a lower bound. And what does it make? What does it make? Ano ba yung gusto ko sabihin? What makes W the greatest among the lower bound? Ayun yung tanong ko. Ano mo nasabing siya yung greatest? Kasi kapag kumuha ka ng any other lower bound T, anong relationship niya sa W? Dapat si W dominates any other lower bound. Okay? Did you understand these definitions? Naintindihan mo yung definitions na ito? Okay. If S is not bounded above, Kung wala kang upper bound, we simply write sup S as infinity. Notation lang ito. Pag wala kang upper bound, natural, no? Parang ang tanging bagay na pumipigil sa'yo sa kanan ay yung infinity. Kaya sup S is infinity. If S is not bounded below, no? How do we write that? We write inf S as minus infinity. Ang tanging bagay na pumipigil sa'yo sa kaliwa ay yung negative infinity. Did you understand? Alam niyo yung definitions na ito, yung mga undergraduate students ko, hilong-hilo dito, no? So, pag tinatanong nila ako, sir, paulit, anong ibig sabihin? Litong-lito sila sa idea ng greatest lower bound tsaka least upper bound. Ang lagi kong ginagamit na paliwanag dito, parang isipin nyo, yung least upper bound or yung supremum, siya yung, imagine niyo yung pinakapangit sa mga magaganda. Halimbawa, ito lahat ng mga magaganda, no? Among doon sa mga ganda, meron doon pinakapangit. Yung greatest lower bound naman, siya yung pinakamaganda doon sa mga pangit. Siyempre, among the pangit, meron pinakamaganda. Kapag sinasabi ko yun, siyempre, tatawanan sila. Tapos, magigets na nila kung ano sabihin ng LUB tsaka ng GLB. I guess, of course, you can understand this better. Halimbawa, if we take the interval S from 0 to 1, this time the set includes 0, okay? Well, kahit na included si 0 or hindi, you know, ang infimum niyan ay 0 at ang supremum ay 1. May tanong ba kayo dito? Whether 0 or 1 is included or not, no, in the set, you know that the infimum is 0 while the supremum is 1. Do you have a question about this? Or is this clear for you as well? Clear ba ito sa inyo? Hello? Is this clear? Or am I disconnected? Ayan, connected ako. Okay. So I don't think we have something to say about this one. On the other hand, for this interval S, nakita nyo, S is not bounded, pero still we can talk about its infimum. Ang infimum niya ay 0, pero ang supremum niya ay infinity. Not to say that infinity is a number. No, that is not to say that infinity is a number. This notation, once again, we write this whenever we wanted to say that S is not bounded above. Now, that's our short for S is not bounded above. Its supremum is infinity. By the way, as a special case, makikita ninyo yung supremum or yung infimum, it could be or it could be not in the set. It could be or it could be not in the set. Kasi may pwedeng nandoon sa set, pwedeng hindi. Halimbawa, look at the first example. Here, the infimum of S is 0 and 0 belongs to S. While the supremum is 1 but 1 is not an element of S. Ibig sabihin, pwedeng ang supremum or infimum ay nasa set or wala. If it happens that that supremum is an element of the set itself, hindi lang meron siyang special na pangalan. Ang tawag natin sa kanya ay maximum of S. Kung on the other hand, yung infimum naman ay element ng S, yung infimum na yun may special na name. We would rather call it the minimum instead of just infimum. Kumbaga yung infimum or supremum, yun yung generic. Diba? Kapag yung least upper bound mo ay nasa loob ng set, hindi lang siya least upper bound. It's in fact the maximum of the set. And kung yung greatest lower bound mo nasa S, hindi lang siya greatest lower bound but also a minimum. Okay. This is the most critical question that will be asked in this lesson, no? Let's say your set is bounded above. Okay? natural na, of course, by the definition, it follows that any other number greater than that upper bound is also an upper bound. Ang tanong, lagi bang merong list among the upper bounds? Would this always exist? Kasi, tingnan nyo, hindi lahat ng number, hindi lahat ng set ay may maximum or may minimum. Right? Hindi ka laging may least, hindi ka laging may greatest for a given set. Ang tanong, if you have a set of upper bounds, among the upper bounds, would there always be the least? Nagkakataon lang that in our example so far, no? Kasi we talk about very simple types of sets, no? Intervals, no? Kapag intervals na kapag usapan natin, medyo madali lang ang usapan. Right? So, ang tanong dito, yeah, must a least upper bound always exist? Or on the other hand, must a greatest lower bound for a set always exist? The truth is, none of the axioms so far will guarantee you that these things will always exist. No? Ano ibig sabihin na sir ng none of the axioms will prove this? Ibig sabihin ko, walang makakapagsabi among the existing axioms na meron na tayo na walang makakapag-guarantee na palaging nag-exist yung dalawa. Now, kung ganon, kung walang axioms ang makakapag-prove or disprove nito, we should choose, no, kung ano ba dapat nating i-axiomatize. And we would rather go for the positive one. Ano sabihin? Gusto natin magkaroon ng least upper bound kung meron kang upper bound. Gusto natin magkaroon ng greatest lower bound kung meron kang lower bound. Gusto natin mangyari yon. So that is the direction that we are going. Halimbawa, bibigyan ko kayo ng example na hindi kasing simple ng mga intervals. Halimbawa, let's consider the set A of ano naman ng A? Ano ibig sabihin ng Q plus? Ang ibig sabihin ng Q plus in this case ay positive rationals, okay? So ang laman ng A natin ay mga positive rationals na ang squares ay less than 2. Okay? Question is A bounded above? Halimbawa, magbigay tayo ng element ng A. Halimbawa, no? You know that 1 is in A, no? Since 1 squared is less than 2 and 1 is a positive rational, right? Is 2 an element of A? Yes or no? Is 2 an element of A? Yes or no?
Yes po.
Yes.
Sure?
Ay,
Tignan nyo, 2 squared. Anong 2 squared? Diba hindi? Diba? 2 squared is already 4 and it's not less than 2. So 2 is not an element of A. So sabihin, we have overestimated the kung meron mang maximum or supremum, no? Sabihin, lumagpas tayo. Kumbaga si 1 nasa A, pero si 2 wala na. So medyo pumunta tayo sa gitna. Ang tanong is 1.5 an element of A? Yes or no? 1.5. Can you hold a calculator with you so we can check? 1.5 is a rational number, right? So take the square. Anong square ng 1.5? 2.25. So yeah, it's not less than 2. So no. So 1.5 is a little high. Okay, babawi tayo. Let's say 1.4. Is 1.4 an element of A? Okay, yes. Kasi ang 1.4 squared, 1.96. Correct? So, sabihin, 1 and 1.4 are elements of A. So, sabihin, pasok tayo sa A, no? Kumanan tayo ng konti, pero hindi too much para umabot ka ng 1.5. Kasi pag umabot ka ng 1.5, wala ka na sa ano no? So try natin 1.41. Ang 1.41 ba element ng A? Can you take the square? Ano yung 1.41 squared? Ay, okay. Pasok, no? 1.9881. So, yes, it is in A. So, tapangan natin. 1.42. What's 1.42 squared? Hindi na, no? Lalagpas na yan ng 2. So, ito hindi na element ng A. Ah, okay. So, we made, yeah. Lumagpas na tayo ng A. So, maybe kaliwa tayo ng konti. 1.41 pero dadagdagan ko ng, for example, 1.45 for 1.5. Ang 1.415 squared, anong 1.415 squared?
Hindi na, sir.
Hindi na, okay. So this is less than 2, so not in A. So atras tayo ng konti. 1.414.
Yes po.
Pasok?
Yes po.
Yes, pasok. And so on. Nakita niya, this time, if I ask you, what is the least upper bound for A? Mahirap sagutin, no? Mahirap sagutin. You know, little did you know, binibigyan ko kayo, no, at this time, binibigyan ko kayo ng algorithm how to approximate the number square root of 2. Di ba? Alam niyo ba, yung ginagawa natin is an algorithm how to approximate the square root of 2. Pero of course, hindi ko sasabihin sa inyo. But, yeah, sagutin muna natin yung tanong na to bago tayo magpunta sa square root of 2. Is this set bounded above? Actually, yes. Kasi, tingnan nyo ha. If, first of all, if R is greater than 2, kahit na yung R, kung siya ay greater than 2, then, of course, ang R squared greater than 2 squared, or 4. And 4 is greater than, sorry, lagpas na siya ng 2, no? Lagpas na siya ng 2. If you take the contrapositively, how do you take the contrapositive of a statement? Inenegate mo to, tapos then ito inenegate. Ang sinasabi natin dito, if R squared is less than or equal to 2, or less than 2, gawin ko na or equal to para pag negate less than 2. If R squared is less than 2, then actually R is less than or equal to 2. So if you take the contrapositive, pag sinabi kong contrapositive, once again, P then Q, ang contrapositive, not Q then not P. In logic, they are equivalent. So in short, ang sinasabi ni sir, ang sinasabi ko dito, therefore, if R is an element of A, R is less than or equal to 2. In other words, 2 is an upper bound for the set A. Kasi kapag nasa A ka daw, ikaw ay less than or equal to 2. That's why 2 is an upper bound. But you know, 2 is not an element of A. Although it is an upper bound, it is not an element of A. What I am trying to find in this example ay kung ano yung least upper bound. Kasi in the previous examples, it's quite easy to determine kung ano yung supremum tsaka yung infimum, di ba? Because these are just intervals. But you see, in this case, it's not always the case that the supremum is readily available, just like in this example, no? We know that 2 is an upper bound. Pag kumaliwa ka sa kaliwa ng 2, diba, si 1 nasa A, it's not an upper bound anymore. Pero kasi pag kumanan, may mas malaking element si A sa 1 na mali. Si 1 ay hindi upper bound kasi may mas malaking element si A, which is 1.4. Ang tanong, si 1.4 ba upper bound? Si 1.4 ba upper bound? Hindi rin. Kasi may mas malaking element si A na naroon pa rin. Di ba? Ito ba list upper bound? Hindi. Kasi meron ulit mas malaking element si A na ano, na nasa loob pa rin ng A. Ang gulo ko, no? Merong mas malaking element si A kesa doon sa 1.41. Now, if you keep repeating this process forever, will you stop? The truth is this algorithm will never stop. Because ang theoretical value ng kanyang least upper bound ay yung number na square root of 2 na tinatawag natin. But we don't know this number in terms of decimals, right? Kasi sabi nyo nga sa elementary mathematics, this number, because it is not rational, sabi nyo, if it is expressed in decimals, it's going to be of infinite length and it's never repeating. Diba? So, this algorithm will actually never stop. And you will be frustrated to know that because you only have a finite number of life, yung algorithm mo will never ever give you the least upper bound. But ang tanong, hindi mo alam yung square root of 2 na yan. Hindi sinabi ni sir sa inyo na square root of 2 yung LUB. Sure ka ba na nag-exist yung LUB nito? And without the knowledge of the square root of 2. Sure ka ba na ang LUB nito ay nag-exist? Let's ask the existence first. Di ba hindi natin masasabi? Ito yung sinasabi ko. Nagkataon lang that in my previous examples, the LUB and whatever, GLB ay madaling ma-identify but not all the time, just like in this example. Okay? That's why we have the completeness axiom. Anong trabaho ng completeness axiom? Ang trabaho ng completeness axiom is the following. Ang trabaho niya, if you have a non-empty set of real numbers and you were able to find an upper bound for that set, ginagaranti niya sa'yo, may upper bound ka, therefore, may least upper bound yan na real number din. Naintindihan niyo? Kumbaga, hindi natin kayang i-prove yung statement na to gamit yung other axioms. No? So we axiomatize it. When you say i-axiomatize, we will accept this as a basic fact para mabuo natin yung real number line. Okay. Do you understand the completeness axiom? Very simple ang claim niya, but this one is very powerful. I am telling you. Most of the results in calculus, no? Most of the important results in calculus heavily relies on this axiom. Hindi nyo lang alam. Little did you know that the entirety of the subject calculus is based on this very foundation. Yeah. Kung isipin nyo ang calculus ay isang bahay, no? Parang bahay kubo. Yung completeness axiom ay isa sa mga paa niya. Tatlo yung paa actually. Yung field axioms, order axiom, at yung pangatlo, completeness axiom. Hindi mabubuhay ang calculus nang wala yung isa dyan sa tatlo. Naintindihan ninyo? Naintindihan ba ninyo? Okay. Ang tanong, naintindihan ba ninyo yung laman ng completeness axiom, yung claim niya, yung kiniklaim niya? Ang kiniklaim niya, basta ang isang set of numbers ay non-empty at may upper bound, sure ka raw na may least upper bound na real number. But it is not telling us kung anong formula para doon sa least upper bound. Basta kiniklaim niya na may least upper bound. Pero tandaan niyo, wala siyang sinasabi kung paano hanapin yung least upper bound. It just guarantees you, para siyang guarantor. Di ba kapag sinabing guarantor, pag nangungutang, siya yung magagarantiya na mababayaran ka kahit mawala yung nangutang sa'yo. Di ba? Ganun yung sabi ng guarantor. Parang ganon, yung completeness axiom is your guarantor. Siya yung magsasabi na, sige, sagot kita, sure na meron yan. Naintindihan nyo? Okay. Kung mapapansin nyo, the completeness axiom talks about upper bounds and least upper bound. No? How about the existence of greatest lower bounds? Hindi na siya kasama sa completeness axiom kasi it can actually be proven. Mapuprove na natin siya ngayon. Once na ikaw ay may completeness axiom na, mapuprove na natin that every non-empty set of real numbers that is bounded below will have a greatest lower bound as well. Bakit? Okay. So this is the proof. I'm going to show you the proof in pictures first, okay? Ang gagawin natin, so this is your number line. Let's say this is the 0. Let's say that's the 0. Imagine nyo na lang yung set nyo ay ito. That's the S. O di ba si S may lower bound? Yeah? Si S may lower bound, correct? Tama ba si Sir? May lower bound yan. Okay. For example, this is a lower bound. You can think of that as your L. Now, what I'm going to do in the proof, pinapakita ko na sa inyo yung proof in general ha, para pag nabasa natin yung proof, masusundan ninyo ng mas mahusay. I-consider natin yung mga negatives ng mga nasa S. Anong sabihin nun? I-define ko yung minus S to be the negatives of those that are in S. Kukunin ko yung mga negative ng mga nasa S. And in my diagram, where is the set minus S? Your set minus S will be a reflection of the S there, no? Kumbaga, kung si 2 ay naririto, kung si 2 nandito, yung negative 2 nandito sa negative S. Did you understand? Hindi niyo ba si Sir? Kung ano laman ng minus S. Okay. Ang tanong ko ngayon, nasa na yung minus ng L? Kung ang L ay mas maliit sa mga lower bound ng S, ang tanong ko sa inyo, nasan yung minus L? Yung minus L will now be an upper bound for, ano? Yung minus L mo will now be an upper bound for minus S. O ngayon, dahil yung minus S ay may upper bound, anong meron siya? Sabi ng completeness axiom, basta may upper bound, meron kang least upper bound. Ayan. So, makakakuha ka pala ng least upper bound. Ito yung tinutukoy ni Sir. Teka lang, pangit ng color. Ito yung magkakaroon ka ng least upper bound. Let's say alpha, kung ano man ang pangalan. Wala na akong maisip na letter. Ipaprove natin na kapag ni-negative mo si alpha, nasa na si negative ni alpha? Pag ni-negative mo si alpha, yung negative ng alpha na yun will be the greatest lower bound of S na pinoprove natin to exist. Naintindihan niyo kung paano gagawin yung proof? Pinakita ko sa inyo yung proof in pictures, but yeah. Ano ba yung, paano yung proof in words? Can I continue? Naintindihan yung strategy na gagawin ko? Sometimes before you write the proof, you have to draw and strategize kung paano mo isusulat yung proof. No? Sometimes drawings can actually help. Naintindihan yung picture ko? Ha? Naintindihan yung picture ko? Ito yung kailangan natin. Okay. So, ang strategy, ang general strategy ko, tignan mo yung mga negative ng mga nandun sa S. Okay? Okay, so let's read the proof. Ay, hindi S ang ginamit ko. Sorry. Ang ginamit ko sa proof ay A. So, let's assume that A is bounded below. May lower bound siya, correct? Ko-consider daw natin yung mga negative ng mga nasa A. Yung bagong set mo, tawagin yung B. So, sorry ha. Medyo iba yung notation dito sa proof. Anyway. Kasi the truth is, hindi ko naman talaga kabisado yung mga proof. But, yeah. Meron akong idea ng proof, but I don't really memorize proofs. Kaya, sometimes the notations will be different. Kung mapapansin nyo, kapag si X ay nasa B, sabihin yung negative niya nasa A. And vice versa. Right? By its definition. So, kunwari si L ay lower bound for A. Katulad kanina, si L ay lower bound for A. Ngayon, kapag si X ay kay B, sabi nung nasa taas, si minus X ay nasa A. At dahil si L ay lower bound for A, dinodominate nung minus X si L. Kasi si L ay lower bound. Ayun, dinodominate ni minus X si L because L is a lower bound for A. But you know very well property ng inequality, pag nag-negative ka on both sides, bumabaligtad yung inequality. So yung X mo less than or equal to minus L. Nasaan ba si X? Nasa B. Kapag si X nasa B, si X less than or equal to minus L. Anong ibig sabihin nun? Ang ibig sabihin niyan, dinodominate ni minus L lahat ng mga elements ng B. So what do you call minus L? Ang tawag natin sa kanya ay upper bound for B. Okay? So by the completeness axiom, what does B have? Anong meron si B? Meron siyang least, upper bound, o yung tinatawag nating supremum. Correct? Tama ba? Meron siyang supremum. Okay. Anong gagawin natin sa supremum na yan? Katulad nung nasa picture kanina, let me go back to that picture so hindi tayo maliligaw. Palitan ko na yung pangalan. Ang pinangalan ko dito ay A. Ito yung A. Sorry. Ang pinangalan ko A. Ito si B. Ito si B. Anong na-prove na natin so far? Nakarating tayo sa point na si minus L ay upper bound for B. Correct? Anong meron si B? Anong meron si B? Meron siyang supremum. Tawagin nating beta. Beta pala ginamit ko, hindi alpha. Sorry, kasi nga naman B, no? Okay. Let beta be the supremum of B. Ang ating gustong patunayan is that kapag ni-negative mo si beta, mapupunta ko ulit sa kanan, di ba? Pag ni-negative mo si beta, siya yung magiging greatest lower bound ni A, nung original na set. In the picture, where's my picture? Yeah, this is the picture. Beta ang ginamit ko sa proof. Sorry. Babaguhin natin. Ang claim natin kung beta ito, yung minus beta is going to be the infimum of A that we need. Naintindihan niyo ba si sir? Can I continue? Ito yung A. Okay. Yeah. Kaya it is important that you know how to draw the proof, no? Kasi the drawings can actually help you, give you an idea. Although it's not a proof, but yeah, it gives you an idea how to write the proof. Okay. Paano natin ipoprove na si minus beta ay ay greatest lower bound? Tandaan nyo, ang pagiging greatest lower bound may dalawang parts. Una, lower bound ka muna. Pangalawa, ikaw yung greatest. Okay? So, let's prove. Ipapakita muna natin na siya ay lower bound. Okay? Paano papakita? Kuha ka ng arbitrary element ng A. Prove natin na lower bound si minus beta talaga. How do you show that? Ganito. Gamitin mo yung minus x. Yung minus x kasi nasa B. Okay? Because beta is what? Because beta is the supremum of B. Bago ka naging least upper bound ka muna. So, anong relationship ng beta at saka ng minus x? Ang relationship nila is that beta must dominate minus x. Now, properties of inequalities. Multiply ako ng negative 1 on both sides, babaligtad yung inequality mo like that. So, what does that mean? Pag si x ay nasa A, dinodominate niya yung minus beta. So, anong ibig sabihin nun? Yung minus beta is a lower bound for A. Kasi na-prove mo na kapag si x ay nasa A, x is just greater than or equal to minus beta. So, minus beta is now a lower bound for A. Okay? Okay. 50% pa lang yan. Ano yung other 50%? that minus beta is the greatest among all the lower bounds. How do you show that it is the greatest? You have to prove that any other lower bound will be dominated by minus beta. Kaya, paano pinuprove yun? Kukuha ka ng kahit na anong lower bound. Sabihin mo B. Let B be any other lower bound for A. Okay? Tama ba? No, but because B is a lower bound for A, yung negative na ngayon, upper bound yun sa B. Remember yung B, ang laman yan yung mga negatives ng mga nasa A. So pag ni-negative mo si B, upper bound yun nung B. Anong meron si B? Si B ay may least upper bound na known. Beta, binigay ito ng completeness axiom. Kung least upper bound ito ng B, ito ay upper bound sa B. Anong relationship meron tong dalawa? Sino ang mas malaki? Ang sagot, mas malaki si, parang mali ito. Anong relationship ng least upper bound at upper bound? Siyempre, least itong si beta, dapat, parang baligtad to. Burahin ko nga muna to. Sige, gawin natin siya from scratch. Anong relationship ng minus B at beta? So, sabi ko si minus B ay upper bound for B. Si beta ay yung least upper bound. Beta being the least, dapat si beta dinodominate ni minus B. Correct? Tama ba? Do you confirm? Do you confirm this? Okay. I-negative mo yung both sides. Pag ni-negative mo yung both sides, pabaligtad to, anong napakita natin? Si B ay dinadominate ni minus beta. So in other words, pag meron kang ibang lower bound for A, dinadominate lang siya ng minus beta. Minus beta is a lower bound as well. So, sino si minus beta? Therefore, si minus beta, siya yung infimum ni A. Kita nyo, mali yung nandiyan sa slide. No? So, the infimum of A is minus beta. So, let me just erase this. Baligtad yan. Ito yung true. Okay? And I think that completes the proof kasi we were able to prove that an infimum of A actually exists. And it's in fact another version of the completeness axiom. Yung completeness axiom kasi natin tungkol sa least upper bound. Itong theorem tungkol sa greatest lower bound. But basically, they are just equivalent. No? Okay. Let's consider this example. Ito'y paboritong set natin to buong semester. Nakikita niyo yung set na ito ng paulit-ulit ng buong semester. Let's consider the reciprocals of the natural number. So, yeah, we have 1, 1/2, 1/3, and so on, 1/4, and so on. Now, in reality, the way we think of A is as follows. Ito yung 1. Let's say this is 0. Ito yung 1/2. Ito yung 1/3. That's how we think about it, no? 1/4, and so on. So, wag kong gawing dilaw yung 0 para wag nyo isipin na miyembro siya ng set. Gawin ko lang puti. Ito yung 0. So, yung set natin ay yung mga, ang points na nandun sa set ay yung mga dilaw. Infinite yan, di ba? Countably infinite. But we will show that the infimum is actually 0. Ano nga yung infimum? Greatest lower bound. Well, medyo malinaw why 0 is a lower bound. Wala bang proof dito? Okay, wala. So let's try to justify. First of all, because n, if n is natural, positive yan kasi 1, 2, 3, and so on, di ba? Tama? Thus, yung reciprocal ng 1 over n greater than 0 rin. Remember, ang reciprocal ng isang positive is still positive. Therefore, 0 is a lower bound for A. Kasi na-prove mo na lahat ng 1 over n ay mas malaki sa 0 and that shows that 0 is a lower bound. Pero it doesn't prove what we wanted to show. Ang pinaprove na ito is that 0 is a lower bound. But what do we want? We wanted to prove that 0 is the greatest among the lower bound. No? So by the way, by the previous theorem, anong masasabi nyo? Anong meron? Can I rearrange this blackboard? Sandali para hindi makalat. So let me just adjust it this way. Hatiin natin yung board sa dalawa kasi para mas madaling basahin pag mas maikli yung width ng paragraph. Okay? Sabi nila may maximum width lang ang paragraph para mas madaling basahin ng mata. Kaya sa palagay ko mas okay. So by the previous theorem, anong meron si A? Ano sabi ng previous theorem? Pag may lower bound ka for A, very good. Infimum of A exists. Ngayon, kung nag-exist yung infimum, pwede mo siyang bigyan ng pangalan. So, kunwari, alpha. Kumbaga, deserve niya magkaroon ng pangalan kasi siya ay nag-e-exist. Ibig sabihin ng nag-e-exist, real number siya. Okay? Okay? Ano natin yun? Jargon natin yun for something, for a real number. Ibig sabihin, something that exists. Because the real numbers is our domain of discourse. Okay? So, let alpha be the infimum of A. Ano yung kailangan nating mapatunayan? We wanted to prove that alpha is 0. So, in our mind, this is what we wanted to happen. Okay. First of all, una sa lahat, 0 is a lower bound. Okay? Alpha is the greatest lower bound. So, meron na tayong alam na relasyon about 0 and alpha. Because alpha is the greatest among the lower bounds, alpha must be greater than or equal to 0. How do we show that alpha is actually equal to 0? So, this is what I do. Look at this, ha? Tignan niyo mabuti. Also, since alpha is a lower bound, bago ka naman maging greatest lower bound ka muna, no? Then alpha is dominated by every 1 over n. Tama ba? Lower bound siya for A. So si alpha dinodominate ng lahat ng 1 over n. Tama? Okay. In particular, kung parang ang sinasabi ko dito sa previous na line, si alpha less than or equal yan sa 1. Si alpha less than or equal to 1/2. Si alpha less than or equal to 1/3. Si alpha less than or equal to 1/4. That's what I mean to say. No? Although, yung sabihin ng expression na for all n. In particular, pag titignan nyo lang yung mga even indices, diba, tatapon mo yung mga add. How do you write that? In particular, ito yung strategy dyan eh. Si alpha less than or equal to 1 over 2n for all n. Sorry, ba't mo naman tinignan yung 1 over 2n? Paano ko may isip yun? Basta, ito yung strategy ng proof na yan. Naintindihan niyo itong in particular, ba't nagkaroon ng 2 doon? Ang ibig sabihin ko, if you just ignore the add terms, tingnan mo lang yung even terms, totoo pa rin naman yan kasi yung mga even is among the 1 over n's. Did you understand? Yung mga 1 over 2n is just among the 1 over n's. Correct? What is true for all is true for some. Okay, so ito na yung trick. Paano ko naisip ng 1 over 2n? Hindi ko alam. Kasi teacher niyo ako eh. Yeah. Actually, Hindi ko masabi kung paano ko siya na i-strategize or naiisip. Pero siguro by experience. This is something that you can learn from reading a lot. Ito, tingnan nyo. Bakit strategy yan? Kasi it follows that pag nag-multiply ako ng 2 on both sides, you get 2 alpha less than or equal to 1 over n for all n. So, anong consequence niyan? Aha, yung 2 alpha, mas maliit ulit sa lahat ng 1 over n. So, si 2 alpha is again, masyadong emotional yun. So, tama nyo, when you write a proof, you avoid to inject emotions. Okay? Kailangan neutral lang yung tone kapag kayo nagsusulat ng proof. Very formal. As much as possible with minimal words. 2 alpha is a lower bound for A. Kasi dinodominate ulit yung 2 alpha ng lahat ng 1 over n. So 2 alpha is a lower bound for A. Okay, ito na. Kung 2 alpha is a lower bound for A, and si alpha is the greatest lower bound, so i-underline ko yung dalawang to. Anong relationship ng alpha at 2 alpha? Anong relationship nila? Anong relasyon ng alpha at 2 alpha? Sinong mas malaki? Kasi yung nagdo-dominate. Sino nagdo-dominate sa kanilang dalawa? Si 2 alpha or alpha? Yes, alpha must dominate 2 alpha because alpha is the greatest lower bound. Do you follow? Okay? So, isusubtract ko yung 2 alpha on both sides. Anong conclusion? Aha! Alpha is less than or equal to 0. Look at this. Yung first of all nyo. Tsaka ito. Pag nagsalib ng pwersa yung dalawang inequalities na yan, what is true? Ang alpha daw greater than or equal to 0. At the same time, it is less than or equal to 0. What can be said about alpha? Anong conclusion? Give me a conclusion. Pag tinignan yung dalawang naka-box, anong sinasabi ng dalawa? Very good. Alpha is 0. That is the infimum of A is 0. So that is how we prove that the infimum is in fact 0. So as you can see, the proof is not really easy to think about, especially when you are beginners, no? Kapag kayo first time magsusulat ng mga proofs like this. And it will never be easy for the entire semester. Most of the proofs will look like this, no? Siyempre, hindi ko naman ini-expect na kayo mahusay na sa pagsusulat ng proofs, no? Kasi I think yung ganitong klase ng mathematics is something that you learn at this level, no? Nung dati naman ang math ninyo noon ay purely computations, etc., no? Yeah. All right. So, anong consequence niyan? Mamaya may consequence to. Tandaan niyo to ha, itong set na to, ang infimum ay 0. Anong consequence niyan? Ang consequence niyan ay yung tinatawag nating Archimedean property. Ano yung Archimedean property? This property is named after Archimedes, obviously. Okay? Anong sinasabi nito? Nakita niyo na to kanina? Yeah. Hindi pala kanina. Saan ba ito nakikita? Anyway, wag niyo munang pansinin si Sir. Imagine niyo sa xi positive. Sa xi positive, okay? Sabi na ito, parang halimbawa si xi isang unit of measure. Kunwari isang ruler. Kasi positive no? Ang sinasabi ng Archimedean property is that, excuse me, sandali lang medyo sinisipon si sir kasi. Dali, ipopost ko lang yung recording at ayusin ko yung sipon ko. Recording. Let's talk about the Archimedean property. Imagine mo si x ay isang positive na number. So imagine niyo x ay isang ruler. Ayan, yung ruler, nasa number line. Whether it's measured in whatever unit, yun yung x. Sabi nito, for any real number y, kahit na nasaan si y, kahit gaano yan kalayo, sabi ng Archimedean property, there exists a natural number n so that nx is greater than y. What does that mean? Kasi if you keep on doing this, and i-times 2 mo si x, nandyan siya, di ba? Pag times 3 mo si x ngayon, ganyan siya. Pag times 4, times 5, times 6, anong mangyari? Eventually, isa sa mga nx ang lalagpasan si y. Naintindihan nyo? Naintindihan nyo ba ito? Eventually, isa sa mga nx has to exceed y. So, do you get the intuition behind this property? Yeah, I hope naintindihan nyo ito because this is so important. Yeah, this is a property that I'm going to use a number of times later. Frequently, many times later. This is what I call, or what we call as the Archimedean property. And in fact, hindi lang ito yung Archimedean property. Marami kasing iba't ibang paraan to state the Archimedean property, and this is just one among those. Ipapakita ko sa inyo yung other forms or other versions of the Archimedean property later. But why is this true? Bakit sure tayo na isa sa mga nx ay lalagpasan ng y? Tatandaan nyo yung mga drawings natin. Ito ay based on our experience. This is not based on the axioms. That's why these pictures don't necessarily give a proof. No? It will give us an idea about the proof, but this will never serve as a proof. Kasi remember, these pictures are only representations and these are based on our experience on dealing with the real numbers. Hindi ito yung based on axioms. Kaya iba yung, pag may pinapakita ko sa inyong picture, iba siya talaga doon sa actual na proofs, no? Sa actual na nangyayari. So, ang goal natin is to actually make them, ang tawag nito? Na nagmamatch silang dalawa. Yung ating intuition, tsaka yung formalism, dapat yung dalawa ay nagsasakto. Ayun yung ating goal. Iko-connect natin sila. Okay. So how do we prove this? First of all, meron tayong case na kailangan i-consider na very trivial. O sige. Let x be positive. Okay? Positive si y, given yun. Let y be a real number. Kahit na positive yan, kahit negative, kahit zero. First of all, hindi ko sa first of all, no? If y is 0, y is less than or equal to 0, kasi ang y real number eh. Kung si y ay less than or equal to 0, we are done. Ang gagawin nyo lang, simply take n to be 1. Pag kasi ang n ay 1, ano mangyayari sa nx? Ang nx mo is just x. Kasi n is 1, di ba? Tapos ang x mo ngayon ay greater than 0 by given siya. At ang y mo ay less than or equal to 0. Kaya ito'y greater than or equal to y. So tapos na tayo, ayan o. Nx is greater than y. Pagka na-achieve natin ito ng madali when y is less than or equal to 0. Ang gagawin nyo lang n daw ay 1. Kumbaga, ang y mo kasi negative eh. Hindi ito yung y mo eh. Kaya when n is 1, automatic yung nx greater than y na. Di ba? Naintindihan niya, ito yung trivial na case. Ang mahirap na case ay yung sumusunod. Paano kapag positive si y? Yan. Ito yung case na hindi trivial. Yung unang case ay trivial kasi mapipinpoint mo kagad sino yung n na mag-work. Ito yung mahirap kasi yung n dito hindi fixed. Di ba? Do you agree? Ang n dito ay hindi fixed. Depende siya kung gaano kalaki si y. Mas malaki yung y, it will require you a bigger natural number. The point is, how will you guarantee that no matter how big y is, merong isang big na n then so that nx is greater than y? That's the idea. Because n will not be fixed for a given y, ang gagawin natin dito, proof by contradiction. Paano yung proof by contradiction? We suppose that the conclusion of the theorem is not true. Dapat magkaroon ng contradiction. Paano ba yung negation nito? Ito eh. So may y ka na, no? Ito yung conclusion. Ang ating ipoprove ay ito, i-underline ko. Pag symbolize mo siya, there exists a natural number n such that nx is greater than y. Pag ninegate natin yan, there exists n such that nx is greater than y, paano mo i-negate yan? Suppose that you always start with suppose pag kayo yung prove by contradiction. Suppose that for all n, sabi ko sa inyo, di ba? Ang negation under exists for all, tapos yung statement, pabaligtarin nyo. Okay, naintindihan nyo? Bakit yan yung negation? Ano sinasabi niyo, sir? Ang sinasabi ko dyan, suppose that, ngayon, di ba, ninegate mo siya using logic. Subukan nyo ngayong basahin in English. Tingnan nyo kung nagmamatch siya doon sa totoong negation niya in English. Kasi ang English, sinasabi, there's some number n, there is some natural number n for which nx dominates y. Paano magiging false yun? False yun kung for every n that you propose, yung nx does not exceed y. Naintindihan niya? Tama ba? Kahit na anong gawin mong n, never mag-exceed yung nx sa y. Yun yung negation. Did you understand? So parang nagmamatch siya. So maybe the way you negate statements is correct. That's one way to verify. Okay. Now, we are going to work on this inequality. Now, this time, x and y are both positive. So, hindi sila zero, hindi sila negative. Hindi ka magkakaproblema sa mga inequalities mo. Yun yung idea niyan eh. Never ka magkakaproblema sa mga inequalities mo kasi positive na pareha si x at saka si y. Ito yung mangyayari ngayon. It follows that anong gagawin ni sir? Magmumultiply ako ng 1 over n on both sides, which is positive. Kapag nagmultiply ako ng 1 over n, x is less than or equal to y over n, correct? Tapos magmumultiply din ako ng 1 over y on both sides. 1 over y. So parang ganito ang ginawa ni sir. Nag-divide ako ng y. At the same time, nag-divide din ako ng n. Naintindihan niyo ba yon? Nag-divide ako ng y, tapos nag-divide din ako ng n. O sige, gawin natin ng mas maayos. Ito yung original. Tapos, subtract natin. Tapos, sige, factor natin ny. Pag finactor mo yung ny, x over y minus 1. Okay? Ganyan, no? Ay, 1 over n to, sorry. Teka, ayusin natin, ha? Tama ba yung algebra ko? Can you check if my algebra is correct? Tama, no? This algebra is correct? Okay. Now, yung n times y, positive to. Let me change the color of that because this is just a comment. Dilaw. Yeah. That thing is positive, product ng dalawang positive. Yung product ng buo, negative or zero. So kung may negative or zero dito, hindi ito ang may kasalanan. Ang may kasalanan ito. Di ba? Tama? Okay. So ano mag-follow? Mag-follow na sa x over y minus 1 over n is less than or equal to 0. Kasi yung ny palaging positive yon. Kung magkakaroon ka man ng non-positive, yun yung other factor, which is x over y minus 1 over n. So it follows that x over y is less than or equal to 1 over n, and this one is positive. Kasi ano? Kasi x and y are both positive. Kaya itong fraction na to ay positive, greater than 0, and less than or equal to 1 over n. And that will happen for all n. Diba? On the right. Ano ngayon yung mali dyan? Remember, we should end up in a contradiction because we're proving it indirectly. So what's wrong with this? Kasi ang pinrove na ito, yung x over y mo is a lower bound for this set. Do you remember this set from the previous example? Pinaprove niya na yung x over y is a lower bound for the 1 over n's. Which is a contradiction. Why? Why is that a contradiction? Kasi, kanina yung infimum ng A, 0. How come na may isang positive na real number ang lower bound ni A kung ang infimum mo 0? Imagine mo, greatest lower bound mo 0, tapos merong isang positive number na lower bound. Pwede ba yun? Pwede bang mangyari yun, guys? Is that possible? 0 yung infimum mo pero may lower bound ka na positive. Pwede ba yun? So, pwede ba? Yes, that's not possible. 0 na ang infimum mo eh. Hindi ka na pwede magkaroon ng any number greater than 0 that is a lower bound. But then, nung inassume natin yung otherwise, nagkaroon ng positive na lower bound yung mga 1 over n. Kaya, what we suppose cannot be true. No? As a conclusion, anong conclusion natin? Therefore, what we suppose cannot be true. Therefore, there must be some n such that nx is greater than y. Hindi na pwedeng wala. Kasi kapag wala, ito yung mangyayari. Pag nangyari to, magkakaroon to ng lower bound na positive, which is not the case. Therefore, there you go. There you have the Archimedean property. So, basically, we were able to prove that such an n exists not by exhibiting it. Hindi natin pinrove yung existence by exhibiting a value for n. No? Anong ginawa natin? We suppose that it doesn't exist. Ang nangyari, nagkaroon ng contradiction. Therefore, it must exist. Naintindihan niya? Yun yung power ng proof by contradiction. Yung existence ng something na prove natin without actually giving a particular value. No? Ang ginawa natin sa proof, yun yung power ng indirect proof eh. Kunwari, hindi totoong nag-exist yung n. Ang mangyari, something weird is going to happen. Did you understand? But as you can see, up to this point, lahat ito'y nakadepende sa completeness axiom. Kasi if you're going to trace back, paano natin na-prove yung Archimedean property? Na-prove natin yung Archimedean property by using the 1 over n property. Eto. Pero tatandaan niyo, hindi naman magagawa itong 1 over n property na to nang wala yung completeness axiom. Actually, hindi yung completeness axiom. Nang wala yung theorem na ito. And syempre, yung theorem na ito is not made possible without the completeness action. Kaya kung itatrace back nyo talaga, lahat ng galing dito sa completeness action. In fact, up to the end of the semester, ito yung very foundation ng lahat. That's why this action is so important. I could not emphasize it enough, but yeah, sabi ko nga sa inyo, kung ang calculus ay ituturing nyo na bahay kubo, ang completeness axiom ay isa sa mga paa. Hindi makakatayo yung bahay kubo nang wala yung paa na yun. Okay? Naunawaan yung Archimedean property before I proceed. Can I proceed to the next one? Okay. The next slides will be the other forms of the Archimedean property, but we're going to have a short break para kayo yung makawiwi or kung anong gusto nyong gawin. We're going to do it in 5 minutes maybe. Anong palagay nyo? 5 minutes? Okay na ba yun? Para na makawiwi, makainom? So I'm going to pause the recording. Okay. Yeah, so this is our basic form, and we will derive some important, some more important properties. Number 1, sabi nung unang form, if A is a real number, there always exists a natural number, capital N, so that N is greater than A. In English, it's like saying that any real number A, any real number is basically exceeded by some natural number. May isang natural number na mas malaki sa kahit na anong i-propose mo na real number. Kanina question natin ito, di ba? Bakit yung N, bakit yung set of natural numbers ay hindi bounded above? In fact, ito yung reason. Kasi kahit anong i-propose mo na real number, laging may isang natural number N that exceeds it. Now, why is this a consequence of the Archimedean property? Kasi if you look closely, you can just set x to 1. Pag ginawa mong 1 yung x doon sa taas, no? Tapos yung little n natin gawin yung capital N. Yun lang naman siya. Diba? Itong equation na to will be that equation. Do you see that? Nakikita niyo ba why this is a special case of the Archimedean property? Tingnan niyo mabuti na yung x gawin yung 1, tas yung little n, palitan niyo lang ng capital N. Kasi normally in mathematical analysis, kapag malaking natural number n, ang ginagamit natin ay capital N if it represents a big natural number. Okay? I hope that you see that. Other version of this is, the fact that n is not bounded above. Kumbaga, the fact that n is not bounded above is not because of anything, but it is because of the Archimedean property. Because kahit na anong i-propose mo na real number, there's always a natural number that exceeds it. And that will prove the fact that n is not bounded above. Okay? And the other form, which is frequently used as well, is the epsilon form. Ito yung epsilon form ng Archimedean property. Sabi nito, for every epsilon greater than 0, there exists a natural number n, so that 1 over n is less than epsilon. Parang sinasabi niyan that if you have a positive number epsilon, however small, usually epsilon is used in mathematical analysis if we want to say that this positive number can be as small as we wish. Usually it represents a small positive number. On the other hand, yung capital N, usually it represents a big natural number. Ang sinasabi nito, kapag may epsilon ka na maliit, may isang malaking natural number na n so that yung 1 over n is even smaller than epsilon. This is quite intuitive, no? Kasi if you think of this as the number line, ito yung 0, ito yung ito yung 1, yan yung 1. And let's say ito yung epsilon mo, and that epsilon is greater than 0 pero maliit. Ang sinasabi ng property is that yung 1/2 nandyan, yung 1/3 nandyan, yung 1/4 nandyan. Eventually, isa sa mga 1 over n has to be smaller than that epsilon. Did you understand? May isang 1 over n that is even smaller than any epsilon that you set as long as it is positive. Naunawaan ba? Yeah, may isang 1 over n na laging mas maliit sa kahit na anong positive na epsilon. Mali ako dun. Sa kahit na anong epsilon greater than 0, may isang 1 over n na palaging mas maliit kaysa sa epsilon. Of course, yung choice mo dito sa n will depend on how small this epsilon is. Usually, mas maliit yung epsilon, it will require a bigger capital N. The question, why is this the Archimedean property? Dito sa form na ito, isa-set niyo yung x to be epsilon, yung y to be 1, tapos yung little n to be capital N. Kasi di ba ang AP ganito, for all y, there exists an n such that nx is greater than y. Yeah. So if you look at this inequality closely, kapag ang n mo ginawa mong capital N, yung x mo ginawa mong epsilon, at yung y mo ginawa mong 1, ganyan siya. And you try to work around with this inequality, that will imply 1 over n is less than epsilon. So I hope that you see why these things are all the same thing, and they are all Archimedean properties. Different versions of Archimedean properties. Naunawaan ba? Naunawaan ba ito? All right. So let's take an example. Okay. For each n from 1 to infinity, let us denote by in the open interval from -1 over n to 1 over n, not including the endpoints. Show that these intervals intersect only at the origin. So what does that mean? So let's try to construct this interval. So maybe this is -1, this is 0, this must be +1. Okay. So where is I sub 1? I sub 1 is the open interval from -1 to 1. That's I sub 1. Now where is I sub 2? I sub 2 is the open interval from -1/2 to +1/2. That's I sub 2. Right? Now where is I sub 3? It's the open interval from -1/3 to 1/3. That's I sub 3. Then we will keep on doing this forever and ever and ever and ever. Habang tumatagal, mas lumiliit na lumiliit yung interval, correct? Yan yung ating intuition. We will somehow prove that these intervals will intersect where? Only at the origin. Kumbaga, ang tanging bagay lang na nabubuhay sa lahat ng mga intervals na ito, kasi intersection, pag intersection for all yan, di ba? The only point that can be in all of these I sub n's, no, is the 0 or the origin. Why is that true? Okay. So this is how I will write the proof. So we will take an element x in the intersection. Now, ano sabihin ng nandun ka sa intersection? We will prove that in our minds, if I let x be in the intersection, in my mind, what I wanted to show is that x must be 0. it must be the only thing in the intersection. So I need to show that x is 0. Correct? Okay. Anong ibig sabihin kapag nandyan si x? By definition of intersection, that means to say, x is in IM for all n. Remember, kapag intersection for all, pag union for some. Okay? So, anong ibig sabihin ng IN? Hindi lang tayo. Sa baba tayo. Thus, for each natural number n, what is true? Yung x mo nasa gitna ng 1 over n tsaka ng negative 1 over n. Nire-write ko lang naman yung kasi yung in open interval. Pag yung x mo nandyan, nasa gitna siya ng dalawang yan. Right? Or, writing this in terms of absolute values, so pwede. Do you remember this? Kapag ang xi nasa gitna ng r at minus r, parehas yan kung sasabihin mo ng absolute value ng xi less than r. Pwede nyo sabihin yung absolute value ng x is less than 1 over n. Now, what we wanted to show here is the fact that x is 0. How do we do that? I'm going to use the epsilon property. Yung epsilon property yung from last week. So let epsilon be greater than 0. I will show you how to use this. Maglalat ka ng positive na epsilon just like this. Gagamitin mo ngayon yung Archimedean property. By AP, there exists a natural number n so that 1 over n is even smaller than epsilon. Kumuha ka ng kahit ng malaking capital N so that yung 1 over n ay mas maliit sa epsilon. Because this is true for all natural number n, and n is a natural number, mag-follow na yung absolute value ng x is less than 1 over n in particular. Kasi this is true for all n di ba? Kaya in particular, you can say this para alam mong ginamit yung general case na nandun sa kanina. Yung absolute value ni x is less than 1 over n. And because 1 over n is less than epsilon, ano mangyayari? Yung absolute value ni x ay less than epsilon for every epsilon greater than 0. If this is true, because epsilon is arbitrary, ano yung sabihin ng is arbitrary? Imagine nyo, yung absolute value ni x ay mas maliit sa kahit na anong positive na number. Anong masasabi nyo sa absolute value ni x? Sige nga, dugtungan nyo what will be the conclusion. If the absolute value of x is less than anything positive, what can be said about the absolute value? Diba pag naglagay ako ng epsilon 0.001, mas maliit doon yung absolute value ni x. Pag naglagay ka ng 0.00001, maraming zero, mas maliit din yung absolute value ni x. If this holds for every epsilon greater than 0, ano dapat yung absolute value ni x? Guys, the only thing possible for the absolute value of x is 0, therefore, x is 0. And that completes the proof. Bakit kinocomplete niyo yung proof? Kasi kapag may x ka in the intersection, it is no other than 0. Therefore, the intersection of these intervals must contain only the origin. Okay? Naintindihan ba? Okay. So, the next property that we are going to talk about, again, as a consequence, ay nagre-require ng isang property from number theory. Kung alam yung property na ito, sige nga, sino nakakaalam nung tinatawag na well-ordering principle sa number theory? So number theory, this principle can be an axiom or it can be a theorem depende kung saan kayo magi-start, no? Sinong nakakaalam ng well-ordering principle from number theory? Anyone? Can you raise your hands if you know this property? Tapos paki-dictate kung anong nilalaman ng well-ordering principle. Sino nakakaalam nito? Number theory na ba kayo? Sino nag-take na ng number theory sa inyo? Not yet? Ano ba? Ay, hindi ko alam kung saan ba daw. Sa number theory ito eh. Sino nakakaalam na lang ng well-ordering principle? Wala nakakaalam sa inyo na itong ano na to, principle na ito of positive integers. Tungkol to sa mga positive integers. Sino nakakaalam na ito? Wala. Okay. Sabi na ito, any non-empty set subset of n, no, has a least element. Yan ang sinasabi ng well-ordering principle. Parang, kumbaga, let's say, meron kang isang basket. No? Mukha bang basket to? Meron kang isang basket. Ang laman nito, mga natural numbers. Ayan, may nag-comment. The well-ordering principle says that the positive integers are well-ordered. Galing, no? An ordered set is well-ordered if every non-empty subset has a smallest or least element. Ito na nga yun. No? So, every non-empty subset S of positive integers has a least element. So, ito siya, basically. Yan. That's according to Google. Kung babasahin natin yung pagkaka-state sa kanya, parang sinasabi niya that if you have a bunch of counting numbers in your bucket, let's say, nandito yung sumama yung 1001, nandyan yung 35, nandito yung 48, nandito yung 39, nandito yung 1 billion 300, whatever. Ayan, kung yun na lang. Nandito yung 149, no? Etc. This set may be finite or infinite. It doesn't matter. Nakukuha na ba yung condition? It could be finite or infinite. It doesn't matter. Sabi ng well-ordering principle, one of the elements has to be the least. Laging may pinakamaliit dyan. Pag dumakot ka ng sangkaterbang positive integers, however plenty or few, no? Laging may isang element dyan ang pinakamaliit. Is that intuitively true? Na-imagine nyo ba why that is true? Siyempre, mga positive integers ang laman yan. Kung makuha mo man sa bucket mo lahat ng mga positive integers, ang pinakamaliit na element, 1, di ba? Pero kung hindi mo man makuha lahat, kasi hindi mo makuha si 1, sure daw tayo na may pinakamaliit dyan. Did you understand the well-ordering principle? Okay. Ang tanong, bakit siya tinawag na well-ordering principle? Ba't siya tinawag na well-ordering principle? Why is it called the well-ordering principle? Alam nyo, reason bakit yan tinawag na well-ordering principle ay ganito. Now, let's say yan yung bucket of integers mo. Okay? Ito yung bucket of integers mo. Sabi ng WOP, isa dito ang pinakamaliit. Kunin mo yung pinakamaliit na yon at ilagay mo dito sa pila. Kunwari n sub 1 yung pinakamaliit. Ngayon, kung may laman pa yung bucket mo, kung may natitira pa dito, sabi ng well-ordering principle ulit, isa ulit doon ang pinakamaliit. Kunin mo yung pinakamaliit doon sa natira. Ipila mo dito. Kunwari, n sub 2 yun. Nakuha niya? Again, kung yung bucket mo may laman pa rin, let's say more than 2 pala laman nito, no? Isa ulit dito ang pinakamaliit. Kunin mo ulit, ilagay mo dito sa pila, and you keep on doing that process hanggang maubos yung laman ng bucket mo. In the end, anong meron ka dito? A well-ordered sequence. No? Sabihin, na-arrange mo yung elements mo from smallest to kung meron mang largest. Kasi possible na infinite collection ito, so walang largest. Pero all the time, lagi kang may least element. It is called as the well-ordering principle because it will allow you to order the elements from smallest to whatever. Did you understand now why is it called the well-ordering principle? Yun yung dahilan kaya siya tinawag na well-ordering principle. Now, ito pwedeng maging axiom. Ayan, tama, correct. In effect, na-arrange mo siya in ascending order. Correct. That's the idea. Or, yun yung ibig sabihin kapag sinabing any non-empty subset can be well-ordered. O, yun yung ibig sabihin yan. Ma-order mo kasi siya. Yeah. Now, may proof ba ito, sir? Depende kung saan ka mag-i-start. Kasi sa number theory, this could be an axiom. This could be an axiom for n or it could be a theorem. Depende kung saan ka nag-start. But, yeah, this is a number theory thing kasi tungkol siya sa mga positive integers. Ang number theory ay yung mathematical study ng mga positive integers. Naka-concentrate lang kayo sa positive integers all throughout the semester. Kaya, yeah, basically dun siya inaaral. But for us, hindi na natin to itatouch. Basta we will assume that this is true. Gagamitin ko kasi siya to prove the so-called floor ceiling theorem. No? Well, ito'y pangalan lang naman na inimbento ko. Pwedeng maging ibang pangalan yan sa ibang libro. No? But I refer to this as the floor and ceiling theorem. Why do I call it the floor and ceiling theorem? Kasi di ba, yung Archimedean property, if you can remember, tungkol ito sa mga natural numbers, okay? Palaki tayo ng palaki. Tungkol ito how the natural numbers are arranged in the line, okay? Yung floor and ceiling theorem will now tell you how all the integers are arranged in the number line. Kasama na dito yung 0 at saka yung mga negative na integers. Paano ba sila naka-arrange? Ayan, basahin natin mabuti yung sinasabi ng floor and ceiling theorem. Sabi niya, for every real number x that you can get in the number line, there's always a unique integer n, could be positive, negative, or 0, so that x is sandwiched between n and n plus 1. No? Si x is sandwiched between n and n plus 1. Do you agree that this is really the case, no? Sa totoong buhay, alam niyo naman na ito di ba? Pero ang totoo, alam niyo siya because based on your experience again. Hindi natin siya alam because we have an objective reason for it. Right? Alam natin na lahat ng real numbers talaga ay kung hindi man siya integer, nasa gitna siya ng dalawang magkasunod na integer. Di ba ganun yun? Alam natin yun. Meron ba kayong objective na reason for that? The reality is we don't have. Until now. No? Ngayon kasi, kung mapapansin nyo, ito ay consequence na naman ng Archimedean property, therefore, consequence siya ng completeness axiom. Kita nyo kung gaano kadaming properties ang madiderive nyo out of that very simple assumption which is called as the completeness axiom. No? Naintindihan nyo ba? Okay? Naintindihan niyo yung theorem before I talk about the proof? Ha? Naintindihan niyo yung theorem? Wala namang mahirap intindihin sa theorem, no? But actually, yung proof niya yung ating pag-iisipan. Yan na nga. yung proof ng theorem na ito will definitely use the well-ordering principle from number theory, which states that every non-empty set of natural numbers will always have a least element. Okay, so let's now write down the proof. So for the proof, you're given any real number. So let's take an arbitrary real number x. How do we show that a number n exists that sandwiches between n and n plus 1? That is being sandwiched by n and n plus 1. No? Paano natin mapuprove na may nag-exist na n? Hindi lang pala existence ito. Nakita nyo, may word na unique. Anong ibig sabihin natin nga ulit ng word na unique? Anong ibig sabihin ng word na unique? Sino nakakaalam ng ibig sabihin ng word na unique? When do we use that in mathematics? What do you mean by the word unique? When do we use that? Anyone? Uy, ano ibig sabihin ng word na unique? Ayan. It refers to the property of being one and only object satisfying a certain condition. Ibig sabihin ng unique, nag-iisa, natatangi sa Tagalog, one and only one that satisfies the condition. Correct. So, ibig sabihin, pag merong n, ilang n ang meron? Ang sagot, isa lang. So, kapag nakikita niyo yung word na there exists a unique, there are actually two things to prove. Paulit-ulit tayo dito. Pag nakita niyo yung there exists a unique, blah, 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 dalawa ang ipoprove nyo. Una, yung existence. Pangalawa, yung uniqueness. Or sometimes, pwede nyo gawin yung baligtad. Uniqueness muna bago nyo i-prove yung existence. Mamimili lang kayo kung anong type nyo doon. Naintindihan nyo? But for our case, existence muna kasi mahirap magpakita ng uniqueness nang hindi mo pa alam kung nag-exist siya or hindi, di ba? Sige. Let's try to prove the existence first. Lalagyan ko dito ng marker. Sabihin, I'm trying to establish the existence first of an n. Now, why do such an n exist? Okay. So, let's now consider an x. Right. First of all, ito na naman si first of all. If x is an integer, we are done. Bakit tayo tapos na kapag x is an integer? Kasi in this case, anong pwede natin gawin? Pwede nyo lang gawing n mismo, si x mismo. Did you understand? You can just take n to be x. So, ang n mo is really less than or equal to x at ang x mo ay less than n plus 1. Kasi ang x mo ay n lang din yan. Diba? So, in short, tapos na yung proof whenever x is an integer. So, for the rest of the proof, we will assume that x is not an integer para may thrill, no? Kasi kapag x ay hindi integer, ito na. Talagang nasa gitna siya ng dalawang magkasunod na natural number. Ang tanong, how sure are you that such a natural number will exist, no? Okay, case 1. Case 1. Ang first case natin is when x is greater than 0. Okay? Ang second case natin when x is less than 0. Pag positive or negative. But walang third case, sir, yung x equals 0. Kasi nga si x hindi na integer. So we will not consider the case when x is 0. So we only consider the case when x is greater than 0. Do you understand? Okay. So, yeah. So case 1, x is greater than 0. So for this case, we will consider the set S. Ang naman ng S, those natural numbers that exceed x. Okay? Ang laman ng S ay mga natural numbers that exceed X. Ang tanong, meron bang laman si S? Meron ba talagang ganyan? Actually, yes. By Archimedean property, alam niyo Archimedean property, no? S is non-empty. Di ba sabi ng Archimedean property kanina, kahit na sinong X ang i-propose mo, laging may isang natural number that will always exceed it. Do you remember that? Is that a thing? Yes, di ba? Yes? Correct? Ito siya, oh. Yung una. Kahit na sinong real number ang ibigay mo or i-propose mo, palaging may isang natural number that will always be beyond the given number. Did you understand? Kaya yung set na ito, hindi yan mauubusan ng laman. Meron palaging element yan. Hindi nga lang natin alam kung ano, basta ginagaranti ng Archimedean property, it's always really the case that there's an n for which n is greater than x. Okay, nasusundan pa so far. Nasusundan pa so far. Okay. Since S is a set of natural numbers, alam mo na ito mga natural numbers, di ba? It's not empty. It's a set of natural numbers. What does it have? Then by the well-ordering principle, ito na siya. Well-ordering principle. Anong meron si S? S has a least element. Sabihin natin, yung least element na yun ay M. So that, okay, being an element, so may dalawa tayong madederive na properties. Okay, first one, M being in S means M exceeds X. Okay? And because M is the least, na yung unang bullet, na-derive ko yan from the fact that M is an element of S. Okay? Now, ano namang sinasabi that M is the least one to be in S? Ibig sabihin nun, pag nag-subtract pa ako ng isa, wala na yan sa S. Do you agree? Do you agree? Siyempre, M is the least integer to be in S. So, if I subtract 1, ibig sabihin nun, wala ka na kay S. Kapag yung integer na yan ay wala na sa S, anong meaning nun? Ibig sabihin, hindi nyo nasasatisfy yung property na to. So that yung n minus 1 dapat less than or equal to x. Agreed? Do you agree? Do you agree with this? Ulit. Si m ay greater than x kasi si m ay nasa s. Si m minus 1 ay wala kay s because m is the least one to be in s. If you subtract 1 further, it will be something smaller than m. So it couldn't be in s. Otherwise, contradict mo yung fact that m is the smallest in s. Naintindihan ninyo? Naintindihan ba ninyo? Okay. Now, if you combine these inequalities, we will get something nice. Actually, itong, yung m minus 1 na to, it couldn't be equal to x kasi si x ay hindi naman integer. Tapos na tayo sa fact na si m ay integer. So, we simply take what? Take n, yung hinahanap nating n, di ba? Take n to be m minus 1. If that is your n, then according to the second bullet, n is less than or equal to x. And according to the first bullet, x is less than m, but m is n plus 1. Diba? From this. M is n plus 1. So I think we are done with the first case. Tama? Tapos na tayo sa case 1. Tama ba tayo? Tapos tayo sa case 1, no? Tama? Nasundan niyo yung proof ng case 1. Ito yung case 1. Nasundan yung proof ng case 1. Nakaharap na tayo ng n na magsa-sandwich. Sorry, nakaharap tayo ng n at n plus 1 na magsa-sandwich sa x. Agreed? Tapos na yung case 1. Can I move on to the second case? Sige. Ano yung case 2? Ang case 2, x is less than 0. Kasi kanina, ang case 1, ang x ay greater than 0. Ang case 2, x is less than 0. Bakit wala ng case 3? Ang case 3 sana, x is equal to 0. Kaya lang, x is not an integer anymore. Di ba? Assume x is not an integer. Kasi tapos na tayo sa case when x is an integer. Okay? So, case 2, x is less than 0. Pag ang x naman less than 0, ganito. Yeah. So, simply just consider minus x. Pag minus mo si x, positive na yun. Di ba? Pag positive na si minus x, apply case 1. Pwede nyo nang i-apply yung case number 1. So, there exists an integer m that sandwich minus x. There are integers m and m plus 1 that sandwich minus x in between. Correct? Tama ba yan? Ganyan yan. Pag in-apply ko yung case 1, may makikuha kang m at m plus 1 na magsa-sandwich sa m sa gitna. Ay, sa x, sa minus x sa gitna. Kasi si minus x ay positive kayo. Ang gagawin nyo lang, all you have to do is to multiply negative 1 on both sides. Ito yung mangyayari. Babaligtad yung inequality, syempre. Okay? Ang gagawin nyo lang, take n to be minus m plus 1. Tapos na. Okay? So, ang mangyayari, n to, tapos ito'y n plus 1. Done. Therefore, if we consider all the cases, the existence of n is now established. Kasi in all of the case, laging may nagsasandwich na consecutive integers kay x. Now, whether x is an integer or x is not an integer. Sa case na ito, naghati pa siya sa dalawang subcases whenever x is positive and whenever x is negative. So basically, yung case when x is negative, dependent lang siya dun sa case when x is positive na ginamitan natin ng well-ordering principle at ng Archimedean property. Okay? Nasundan niyo yung proof ng existence. Nasundan na yung proof of existence. Bakit tapos na yung proof of existence? Tama? Yes? What do you think? Hoy. Nasundan ba yung proof of existence? Alright, sige. Now, let's now go to the proof of the uniqueness. Ito na yung second part ng proof. Kasi, ang ano lang naman, ang claim natin ay may unique na n kung may mag-exist. Na-prove na natin na nag-exist. Bakit isa lang yung n? So, paano nagpo-prove ng uniqueness na nag-iisa lang yung n? Kunwari may dalawa. No? Suppose that n1 and n2 are integers. Say, sabihin na lang natin si n1 yung mas maliit sa n2. Satisfy. Kunwari nasa-satisfy nila yung property na gusto natin. Nasa-satisfy ni n1 at the same time nasa-satisfy ni n2 yung same inequality. No, kunwari, yan ay totoo. Anong mangyayari, no? What will be the case really? ganito. Tingnan nyo to. Since N2 is greater than, since N1 is greater than, mali. Since N1 and N2 are integers and N1 is less than N2, what can you say about N2 minus N1? What can you say about the difference between N2 and N1? What can you say about this? Mga integer sila. Pagkatapos, mas malaki si N2. So, ibig sabihin si N2 minus N1 is a positive, and is an integer. Correct? Kaya ang smallest possible value ng N2 minus N1 ay 1. Okay? Tama ba? 1 ang smallest, kasi ang N1 at N2 parehas integer. So, ang N2 minus N1, integer. Because N1 is less than N2, ang N2 minus N1 ay positive. So, in short, yung N2 minus N1 is a positive integer. So, in short, ang smallest possible value ng N2 minus N1 ay 1. So that, ano mag-follow? Yung N1 plus 1 ay less than or equal to N2. Thus, ayun na, tapos na tayo. Yung X natin, according to this inequality, tawagin natin 1 at 2. To 3. Okay? So, yung X according to inequality 1 ay less than N1 plus 1. According to inequality 3, ang N1 plus 1 is less than or equal to N2. Okay? And then according to inequality number 2, this is less than or equal to X. Therefore, X is less than X. A contradiction. Kasi ang X hindi pa pwedeng maging less than itself. Therefore, what we suppose cannot be true. Hindi pa pwedeng may dalawa na magkaiba, di ba, na N1 at N2. Ang pwede lang na mangyari talaga is that N1 is equal to N2. Therefore, the uniqueness is now established. And we are done. Alam niyo ba tinawag na floor and ceiling theorem ito? Alam niyo ba tinawag na floor and ceiling theorem ito? Kasi if X is a real number, the unique n such that this is true is called the floor of X, yun yung pangalan, denoted by ganito yung notation. Parang absolute value pero may paa. Okay? Yeah, floor. Sino naman yung n plus 1? Yun naman yung parang, hindi, mali eh. Ano ko ba i-define ito? Wait. Let me rephrase the definition for you, okay? Let X be in R. So let me change the definition. Okay. Number 1. If X is an integer, define na natin yung floor niya as itself at yung ceiling niya as itself. Ang floor at ceiling ng isang integer ay sarili lang nila. Okay? If X is not an integer, ito na yung maganda na. If X is not an integer, say, X is between n and n plus 1, sabi ng theorem, may n at n plus 1 na nagsasandwich between X, diba? That's sandwiching X in between. Correct? Yung floor ni X ay yung n, at yung ceiling niya naman ay yung n plus 1. Ang tawag natin dito sa ganito, you call this a floor of X. And this one is the ceiling ceiling function tsaka floor function. Ganyan ba spelling yung ceiling? Tama ba si Sir sa spelling ng ceiling? Did I spell it correctly? Yeah. Sige nga, example tayo kung naintindihan niyo yung floor at ceiling. O sige, anong floor ng 2? Siyempre 2. Anong ceiling ng 2?
2.
2 rin. O, same integer. Pag integer ang number, ang floor at ceiling, same integer. Okay? Nagkakaiba yung floor at ceiling kapag hindi integer yung number. Halimbawa, 2.64. Anong floor nito? 2 pa rin. Pero ang ceiling ng 2.64 ay ano?
3.
Very good, 3. How about the floor of negative 2.64?
Negative 2.
Ano yan? Palito na kayo bigla.
Ay, negative 3.
Negative 3. This is now negative 3. Ang nasa kaliwa niya na integer ay negative 3, hindi negative 2. Okay? Pag negative, ang order ay baligtad. Please take note of that. So, ang ceiling ng negative 2.64 ay?
Negative.
Negative, ano?
2.
Negative 2. Very good. Of course, this goes for any real number, including those which are the weird numbers. Halimbawa, yung square root of 2. Anong floor ng square root of 2? Ay, ceiling muna. Anong ceiling ng square root of 2?
Yung
2. Ang floor niya ay 1. Kasi di ba ang square root of 2 is 1 point something, 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 something. Okay. So, ang floor niya ay 1. Ang ceiling niya ay 2. Pero sa ngayon, hindi nyo pa alam yung square root of 2. Ha? Magpapanggap kayo na hindi nyo pa alam yung square root of 2. Hindi pa natin na i-define. Ano yung sabihin ng square root of 2? Papunta pa lang tayo doon actually. Kung mapapansin nyo, we're going from below to up. No? From down to up. Pag-start tayo sa natural numbers by specifying the Archimedean property. Now we have the floor and ceiling theorem. For the integers, anong natural na next step? Ang next step ay mga rational numbers. Kung paano naman naka-arrange yung mga rational numbers sa number line. Yes, correct, Jesserine. Yung floor function is also called as the greatest integer function sa calculus. If you are teaching a calculus course, you might have encountered the greatest integer function. The greatest integer function is the floor function. Pareha siya sa floor function. Yung ceiling, I don't know kung anong counterpart niya sa calculus, but yeah, meron tayong floor at ceiling function. Yung tinatawag nating greatest integer function sa calculus is the floor function here. Naintindihan ninyo?
yes po, sir.
Okay, so let's continue. So tapos na tayo sa mga natural numbers, tapos na tayo sa integers. Nakita natin na ganito sila nakakalat. So totoo pala ang chismis. Kasi yung fact na ang mga integers ay ganito, lahat ng ganyan ng arrangement, totoo siya, may proof na tayo. At ang proof natin ay yung floor and ceiling theorem na kahit na anong real number ang kunin mo, nasa either integer siya or nasa gitna siya ng dalawang magkasunod na integer, totoo yun. Ito yung proof na yung floor and ceiling. Ngayon, nag-make sense na yung drawing natin na ganyan, na yung real number line ganyan. Ngayon, nag-make sense na siya. And you will never look at the real number line the same way again, no? Kasi ngayon parang nagkakaroon na ng realizations. Next, nasa ang parte ng real number line ang mga rational numbers. Ayan na tayo, papunta na tayo sa exciting part. Pagkatapos ng mga rational numbers, pag-uusapan naman natin yung mga irrational. Okay? Unti-unti lang hanggang mabuo natin yung buong real number line. So you see how the story develops. No? Bawat chapter, bawat module doon sa ating instructional material, kung mapapansin nyo, may story na ina-unfold. Hindi yan basta listahan lang ng mga theorems na unrelated. In fact, bawat chapter nung instructional materials natin, in-arrange ko yan so that it will unfold a particular story. So basically, yung module 1 na makikita nyo, no, siya ay kwento ng real number line. Na-realize nyo ba? Kasi minsan pag nagbabasa tayo ng libro, di ba, parang tinitingnan lang natin ang libro na as if it's just a list of definitions and theorems and whatever, no? But minsan nami-miss natin yung pinaka-point ng bawat chapter. Bakit ba chapter ito? Ano bang point ng chapter na ito? Should always remind yourself to look for that part. Ano bang purpose ng chapter? Yun, ang purpose ng chapter 1 is to tell you the story about the real numbers. Okay, ang susunod. Nasaan yung mga rational numbers? Let's say, kung ito yung ating representation ng number line, let's say this is the 0. Ang mga rational numbers ba nasa isang side lang na number line? Ano ba, nandito lang ba sila? Or nandito lang ba sila? Nasaan parte ba ng real number line ang mga rational numbers? Anong palagay ninyo? Anong palagay ninyo? That cannot be the case kasi alam nyo, ang mga integers mismo ay rational numbers. Di ba? They are part of the rational numbers. Pero maliban sa kanila, meron pang ibang rational numbers. May 1/2, may 3/2, may 5/2, etc. etc. Sa gitna niyang mga yan, yung mga midpoint, mga rational numbers pa rin yan. Di ba? Sa gitna ng mga yan, mayroon pa rin mga midpoints yan, mga rational numbers ulit. Right? Kung mapapansin nyo, parang napakaraming mga rational numbers, no? In fact, that is true. Kaya nga, meron tayong tinatawag na density theorem. Di ba? Yung word na density, halimbawa, pag sinabi that Manila is densely populated. Pag sinabing Manila is densely populated, what does that mean? It means to say that in a small area, a lot of people are living there. Sangkaterbang tao ang nabubuhay sa maliit na area. So sa real number line, kaya tinawag na density theorem ito for Q is because kapag kumuha ng kahit na anong maliit na interval, kahit gaano yan kaliit, no, however short, there are infinitely many rationals here. Okay, that's the next thing that we are going to establish. In any open interval, however small, however short, there are always infinitely many rational numbers. That's a fact. And this is the basic statement of what we call as the density theorem for rational numbers. Let me emphasize that this is for rational numbers. Okay? So maraming density theorem sa mathematical analysis and this is just one among those. Ano sabi? If you take any two real numbers, no? Any two real numbers x and y where x is less than y, ano sabi? In fact, there is always a rational number in between. Ang tanong, bakit sabi mo kanina, sir, infinitely many? Oo, kasi kung ito yung x at saka yung y, may rational number sa gitna nila. Tawagin mo R1. Alam nyo, kung i-apply nyo ulit yung density theorem dito sa dalawang intervals na to, makakakuha ka ng another rationals. Ngayon, sa mga intervals na to, i-apply mo ulit yung density theorem. Makakakuha ka ulit ng another set of rational numbers. Do you get the idea? So if you keep on applying the density theorem, in fact, you will end up concluding that, in fact, hindi lang isang rational ang nag-exist sa gitna ng x and y. In fact, there are infinitely many. But we will only prove the basic result. The basic result tells us that between any two real numbers, kahit na nasaan sila, basta may between, no? Anong conclusion? Palaging may rational number na makikita sa gitna. Imagine niyo, ganun ka-dense ang mga rational numbers. Kahit gaano kalapit yung x and y, palaging may lulusot na rational number sa gitna. Amazing, no? And I think this is something that you might be familiar already based on experience once again. But ngayon, nagkakaroon na ng meaning lahat, nagkakaroon na tayo ng proofs. In fact, yun naman talaga ang point ng subject na ito. Yung mga bagay na napag-aralan na natin but we tend to miss out, no? The details, the important details, ngayon natin pinupunuan yung mga detalye na nilagay natin sa ilalim ng basahan when we were studying this before. Ito yung mga bagay na hindi napapag-usapan but now, nabubuhay sila para mga multo, no? Hinahabol tayo. Sige, let's write the proof. So, let x and y be reals where x is less than y. Ang tanong, saan kamay ng Diyos mo kukunin yung rational number na nasa gitna ng x and y? What's the strategy? Okay. Makikita ninyo, gagamitin ko yung dalawang theorems na na-discuss natin kanina, which is the Archimedean property and the floor and ceiling theorem. I'm going to use them ng sabay. And makikita nyo, ma-establish natin yung gusto nating malaman. First of all, because x is less than y, ang y minus x ay positive. Right? And because y minus x is positive, by the Archimedean property, there will exist a natural number n large enough, no, so that 1 over n is less than y minus x. Yung n na yan ay large enough so that yung 1 over n is even smaller than y minus x. Yung y minus x, yan yung haba ng space sa pagitan ng x at saka ng y. Kung maikli yan, kung malapit sa x and y sa isa't isa, yung n na yan malaking-malaki dapat. Di ba? Naintindihan nyo? Pero kung ano malayo sa x and y, siguro pwede ng n is 1. Na? Right? Pero kung ang x at y malapit na malapit, just in case na malapit sila, yung n na yan has to be very big para yung 1 over n ay mas maliit even sa y minus x. Do you understand? Okay, kung ano yung n. Okay. How do we continue from here? Ang gagawin ko, I will consider the product of capital N and X. Ano yun? I-multiply ko yung n na yan sa x, tapos kukunin ko yung floor. Oh my gosh. Kasi hindi tayo sure kung yung n times x ay integer or hindi. Di ba? But to make it an integer, kukunin ko yung floor nung n at n times x at tatawagin ko yung floor na na m. Okay. Ang tanong, what is the property? What is the property of this floor? Ang property niya is that it sandwiches m and its consecutive integer m plus 1 sandwich nx in between. Okay? So, meron tayong dalawang inequality ha. 1 tsaka 2. Tatawagin kong inequalities 1 and 2. So, you know what will happen next. Therefore, mag-start ako sa x. Tingnan nyo ha. Tingnan nyo mabuti. Walang kukurap. Nandito yung proof. Gagamitin ko yung inequality number 2. Okay? Sa inequality na to, yung x is less than m plus 1 all over capital N. Do you agree? From inequality number 2, you can say that x, because n is positive. So that will follow. Okay, property ng division, ito yung m over n plus 1 over capital N. Correct? Okay, step by step, i-confirm ko kung nakukuha nyo. M over N plus 1 over N siya, correct? Okay. Now, from inequality 1, I'm going to use this now. Anong masasabi ko sa M over capital N? Di ba dito, mula dito, ang M over capital N less than or equal to X, correct? Correct. Kaya ito'y less than or equal to X plus 1 over capital N. Correct? Tama ba si sir? Sige, tama, no? Ngayon, from this inequality, I call it inequality 3. Nakikita niyo inequality 3, ito. Yan. Yung 1 over N, mas maliit sa Y minus X. So, I can write here less than Y minus X. Anong ginawa ko? 1 over N was replaced by Y minus X. And that resulted to Y. Oh my gosh, this is something nice. Why is this nice? Kasi, kung titignan nyo mabuti, if I take R to be M plus 1 over N, remember, M is an integer, N is a positive integer, therefore, M plus 1 all over N is a very nice rational number, no? Ano na pala natin? Yung R na yan is greater than X, at the same time, it's less than Y. And we are done. Ganun lang kasimple yung proof. Nakita nyo, no? Nakita nyo what? How we were able to prove the existence by construction. Ito naman yung proof of existence by construction na tinatawag. Pag sinabing by construction, you are actually constructing that element na pinoprove mo na nag-e-exist. Pinoprove natin that a rational number R exists between X and Y. In this case, hindi tayo nag-prove by contradiction. We prove it by construction. Kasi kinonstruct natin, sinabi ko sa inyo kung paano ginagawa yung R sa pagitan ng X and Y, and it actually worked. Nice, no? Nasundan niyo yung proof? Nasundan niyo ba yung proof? Tama? Okay. Next na tayo. Alam nyo, walang rational number ang may square na equal sa 2. Ito yung paulit-ulit na pinag-aaralan kahit sa elementary mathematics na walang rational number ang pwede magkaroon ng square na sa saktong 2. Kasi alam niya kung meron, no, proof, let's say, kung meron, let R be rational so that R squared, hindi. Suppose that, hindi pa pwedeng let kasi hindi tayo sure kung meron, no? Sabihin natin, suppose that R is a rational number and R squared is equal to 2. Paano natin ipaprove na false yan? Kailangan magkaroon ng contradiction. Okay? Paano ba yung proof nito? Naalala nyo? Ang proof nito is isusulat natin yung R as P over Q, where, ano yung P at Q? Si P ay integer, si Q ay positive integer, tapos ang gusto ko, ang GCD nilang dalawa ay 1. Ibig sabihin ng GCD ng numerator at denominator ay 1, it means sa yung fraction na to naka-lowest form. No? Naka-lowest form. Or in its simplest form. Kasi halimbawa, yung 2/4, no, hindi yan naka-lowest form kasi ang GCD ng 2 at 4 ay hindi 1. Masasabi mong naka-lowest form kung ang GCD ng numerator at denominator ay equal to 1. Did you understand? Did you understand me? Naintindihan ba? Okay. Ano mangyayari ngayon? Ay, kuha tayong puti. Now, dahil ang R squared ay 2, paano mo sinasabi ang P over Q squared is equal to 2? That is P squared is equal to 2q squared kapag yan sinimplify mo. Which will mean p squared is even. Okay? Kasi p squared has a factor of 2, which will eventually mean that p is even. Kasi ang square ng isang add ay add. Kaya hindi pa pwedeng maging add si p. Diba? Ang square ng add ay add, so hindi pa pwedeng maging add si p, dapat si p ay even, kung ang square mo ay even. Ngayon, so si p ay even, so pwede ko siyang isulat as 2k, where k is another integer. O, tapos, anong gagawin mo? Yung 2k na yan, isa-substitute mo dito. Okay? Anong mangyayari? 2k squared equals 2q squared, magiging 4k squared is equal to 2q squared, tapos divide ka ng 2, q squared is what? 2k squared. Again, this will mean q is even. Therefore, p and q are even. Contradiction. Why is that a contradiction? Sabi nyo ang GC naka-simplest form tayo. Ba't naging pareho silang even? It cannot be. Kasi kung pareho silang even, may common factor sila na 2. So the GCD can't be 1. So that's a contradiction. So therefore, there is no rational number whose square is 2. Tama? So confirmed na to? Tama? Ganyan yung proof na ano. Walang rational number na ang square ay 2. Pero ang tanong ko, is there? So my question is there a real number whose square is 2? So this is our question next. Kung walang rational number na ang square ay 2, ang tanong, meron bang real number na ang square ay 2? Kung meron man, no? Kung ang sagot natin ay meron, ibig sabihin nun, that only proves one thing. Aha, it proves that there are numbers or there are real numbers which are not rational. For the first time ever in this class, mapapatunayan natin na mayroong mga numbers, may mga real numbers na hindi rational numbers. And dahil nakapag-exhibit ka na ng example, bibigyan na natin sila ng pangalan. Tatawagin na natin sila ngayong mga irrational numbers. Pero bago natin yung magawa, kailangan muna natin masagot yung tanong na to. Meron ba talaga mga real numbers na ang square ay 2? Kanina, sabi, walang rational number na ang square ay 2. Kaya ang tanong natin, we improve the question. Meron bang real number na ang square ay 2? Kung ang sagot dito yes, maganda. Na sabihin, merong mga numbers na hindi rational. Aha, kaya pala may mga tinatawag na irrational numbers. Yeah. Did you understand? So next time, we are going to answer this question. In fact, we are going to answer a more general question. We will replace 2 by any positive number. At hindi lang square. Ito, papalitan din natin ito ng yung square. We will try to replace it by the nth power. That's what I call as the nth root theorem. Ipapakita natin next time, before we start the next lesson, that if a is positive and n is an integer greater than 1, ipoprove natin that there is a unique positive x such that x to the n is equal to a. Wala akong sinasabi kung si x ay rational, mas ang sinasabi ko may unique positive real number x for which x to the n is equal to a. Ibig sabihin, lahat ng positive numbers may nth root for any n. Pag sinabi kong may nth root, ibig sabihin nun, may real number na ang nth root ng nth power ay a. Imagine niyo no, kaya nating i-prove na nag-e-exist sila. Kasi alam nyo, sa totoong buhay, naniwala lang naman kayo na may square root of 2 kasi sinabi ng teacher nyo. But your teacher did not actually guarantee the existence. Sinabi nga lang by authority, no? By authority. Ang square root of 2 pag ini-square nyo sa saktong 2. Pero ang tanong, natunghayan nyo ba kung ano talaga yung square root of 2 na yon? In fact, wala nga kayong proper decimal expansion yan eh. Yung decimal expansion yan, nakita nyo lang yung few decimal places. But in reality, naniwala lang kayo sa teacher nyo. Kasi ang mathematics nung napangbata, no? Usually mga math na tinuturo natin sa mga pangbata, ang parang ano yun eh, mathematics by belief, no? Parang ang math nun parang religion. Basta sinabi ng teacher, yun na yung totoo. But yun, kaya magbabago yung ating pananaw ngayon kasi every statement that we claim and we wish to claim that meron tayong proof. Hindi pa pwedeng sasabihin mo lang na may square root of 2. Ano yung proof mo na merong number na ang square ay 2? Diba? So that's the next thing that we have to do next time. Naku, 10:30 na pala. I have to stop the recording. I'm so sorry. Medyo na sobra tayo.